Let's look at debugging programs. Now, what is a bug? A bug is simply a problem with your code or any unexpected output, also called an error. The process of finding these errors or bugs and removing them is called debugging. So to successfully run a program, you must find all the types of errors from your code, and there are many different types of problems that can occur in the code. Syntax errors are usually caught by the editor or the interpreter or the compiler, and many times the error will give you a line number and maybe an exclamation of what the problem is. Editors can show different colors or highlights in your code when there are errors. Upper and lower case, keyword misspellings, adding or leaving off S's at the end of words, or forgetting to put a statement terminator like a semicolon are examples of syntax errors. Typos like missing parentheses or passing arguments in the wrong order are other examples of typos, but these might not be picked up by the editor, interpreter, or compiler, but you will get the wrong output or results while running the program, which brings us to our next type of errors. Runtime errors occur due to illegal operations, meaning you didn't follow the rules of your programming language. You detect these errors when the program is running. The running program is then stopped or crashed, and a diagnostic message is displayed on the screen. This might happen when something unexpected happens, like your user inputs text or a negative number when they're supposed to input a positive number, and you, the coder, didn't account for this possibility in code. Or in other words, you didn't include error checking in your code. Perhaps a number gets divided by 0, or you try and access memory that's not available to you. Okay, logic errors happen when your logic is flawed. Your instructions might work, but don't do exactly what you expected, creating unpredictable results. You could have used the wrong operator by maybe putting a minus sign when you should have added, or using the wrong sequence of instructions. This error can be difficult to detect. The program continues to run, but the wrong output is generated. So let's look at some debugging strategies to avoid having bugs. The most important strategy is to avoid the bugs you write in the program in the first place. If you have planned out your system completely with pseudocode or flowcharts, and your logic works flawlessly there, your logic will probably be fine once you translate the plan to code. This is a step that many programmers skip. It's going to lead to all sorts of problems as they code if they don't do it. It is very important to think it all through before you code. All of the effort spent in designing and planning before you even code will pay off later. The goal is to write error-free code in the first place, not to become an expert at fixing bugs. You shouldn't be proud when you fix a bug, but embarrassed that you had a bug in your code in the first place. You should also program incrementally, which means you should code small amounts and then check and run your code as often as you build. This way, when there is a bug, you know it was the last bit of code that you added that caused the bug. You can also use, you can log your information with print statements or console logs. These are bits of information to take a look at as you code that won't necessarily be output in the final system, but can help you keep track of what data is being processed in the code. You could use debugger tools that might be available for your code. A lot of code editors will have built-in or plug-in developer tools to help you debug your code. You can set breakpoints in the program, step into and over different sections, and monitor variable contents to discover errors. Lastly, make sure you're looking at or running the right code. you might be opening the wrong file to run and then looking at a different file's code. Also make sure the right frameworks or library files are linked up properly. These debugging strategies will be used throughout all of your programming control structures that we talk about and will serve you well if you can be good at debugging your code in general.